fundamental square, you know this. Also, the graph of Boyle's law. So since this is directly, so that means if you want to have a straight line graph, it is basically your volume against your 1 over P. So if you have volume against P, you will definitely, the graph will not incline this way. The graph will not incline this way. You have something like this, or let me say you have something like this. So that's a graph of, because V is not directly proportional to this, so you have a bend. But in the case of V is directly proportional to 1 over P, then you have this. So you can have so many other examples. Then you also have Charles' law, and Charles' law is talking about Charles' law. Charles' law talks about the volume of a given mass of gas is directly proportional to what? Temperature, provided the pressure remain constant. So in this situation, you have also the graphical representations. Now, so the Charles law, the graphical representation, you know, since your volume is directly proportional to temperature, you definitely have a graph like this, VT. Then it will be, you have something of this. Then if you have let's say VT over T, for example, then you have a horizontal scenario like this. So this is a typical example of graphical representations as far as Charles' law is concerned. And the next thing we need to talk about is what they call absolute zero temperature. Absolute zero temperature, which has a graph temperature, which has a graph of this kind. Have a volume here, they have a temperature. The here is minus 27.3 degrees Celsius. So that is the graph of this, your absolute zero temperature. So absolute zero can be defined as the temperature of that gas, so which is usually minus 273 when it is theoretically, when the pressure is theoretically reduced to what? Zero. The temperature, which is usually this, of the gas, when the pressure of the gas is theoretically reduced to zero. That is the absolute zero temperature. Then we also have Kelvin temperature. Kelvin temperature, because the relationship between Kelvin and degrees Celsius is that when you have your Kelvin, degrees Celsius plus 273, so this is the relationship. So, and majorly, when you are talking about gas law, especially Charles' law, if your temperature is given to you in degrees Celsius, you need to add 273 to it so that you convert it to what? Kelvin, because we work with what? Kelvin. That temperature is measured in Kelvin, not degrees Celsius or degrees centigrade, because when it is given to you in degrees Celsius, all you need to do is to add 273 to it, then it becomes your Kelvin, which you are going to use directly in any calculation. Then the general gas law. The general gas law is going to incorporate both Charles' law and Boyle's law. It will incorporate both Charles' law and Boyle's law, and at the end, you are going to have PVT is constant. So what it means is that P1, V1 over T1 is equal to P2, V2 over T2. So it incorporates both Charles' law and Boyle's law. So take note of that. Then the next one is Dalton's law of partial prior. Dalton's law of partial prior, which talks about that it states that if there are a mixture of gases which do not react chemically together, the total pressure exerted by the mixture is equal to the partial pressure of the individual gases that make up the mixture. So what am I saying? So if you have, let's say, A, B, C, so the total pressure that is exerted by the mixture will definitely be the partial pressure of the individual gases that make up the mixture. So it has this formula like that. That is your. So when you see a scenario like this, it's talking about Dalton's law of partial pressure. Now, it has PT equals to P1, PA plus PB plus PC plus etc. So also, you can also have where this T is standing for what total. So P total can also be P gas plus P water vapor. So you have P gas plus P water vapor. So if you are meant to do or to perform any calculation involving Dalton's law of partial pressure, these two formulae are of significance. So let's see. Then the next one we're going to be talking about is ideal gas law. Ideal gas law has the formula PV equals to nRT, where P is the pressure of the gas, V is the volume of the gas, N is the number of moles, R is the general gas constant, YT is the temperature in Kelvin. Then if you now have 1 mole of that gas, then the formula becomes PV equals to RT. So when you have 1 mole, it becomes PV equals to N equals to RT. Then let's talk about deviation of real gases from ideal gas. What is the major concept here in the deviation of the real gas from the ideal gas? Is due to the fact that unlike ideal gases, the molecules of the real gases occupy space and there are forces of attraction between them. So you have, because of the division is as a result of the fact that the real gases occupy space and there are forces of attraction between them. That's the difference. That's what led to that deviation. The next one is Gay-Lussac's law. Gay-Lussac's law is the theory of gases. It is pertaining to gases. So in Gay-Lussac's law, it states that when gases react, they do so in volume, which bear in simple ratio to one another and to the volume of their product, if gaseous, provided temperature and pressure remain constant. Let's also talk about Avogadro's law or hypothesis. It states that equal volume of all gases at the same temperature and pressure contain the same number of molecules. Then the last one is the Graham's law of diffusion. Graham's law states that the rate of diffusion of a gas is inversely proportional to the square root of its density, provided temperature and pressure remains constant. Let's consider the commonly tested UTME questions as regards to this topic. Now, the first question says that calculate the percentage by mass of nitrogen in calcium triazonitrate 5. So at this level, we should know how to, because this is UTME, which is advanced stage of the secondary school lessons. So in UTME, at this level, in your secondary school, you should have known how to form a compound given the respective ions. So if you are talking about calcium triazonitrate 5, so you are having calcium coming together with nitrate. So how would they combine to form a compound? Simply, it will be, this one is -1 and this one is +2 charge. So automatically, when you cross this, there are charges, then you have this. So this one is 1 times A, Ca, 2 times this, then you have it like this, NO3, 2. So this is the way it will combine to form a compound. So but the question is asking us to calculate the percentage by mass of nitrogen in calcium trioxonitrate 5. So in this situation, all we just need to do is to recall the relative atomic mass of this respective element. For calcium, it is 40. For nitrogen, it is 14. For oxygen, it is 16. So that's what we are going to have. So if you open this one up, we are going to have Ca N2O6. And the question is now asking us for, how do I get N2? This is like, assume that it is 1. 1 times 2, 2. So you have 2, N2. Then oxygen is O3 here, multiplied by 2, making it O6. Now, the question asks us to calculate the percentage by mass of nitrogen. So how many nitrogen do we have in this system? We have 2 of them, 2 atoms of nitrogen. So we have 2N into the whole of what you have. So in this situation, so how do you calculate percentage by mass of an element? Percentage by mass would definitely be that element over the compound incorporated by that element times 100/1. Then in this situation, what do we have? Nitrogen is 14, so you have 2 of it, so you have 2 times 14 over calcium is what? 40.